the next thing that we're going to talk about is called the normal distribution curve. Okay? When a distribution of an athlete's performance is considered normal, what are the three characteristics that it has? It's on the quiz yesterday.
That bell-shaped thing.
Okay, it's bell-shaped. What else? Unimodal. What's the last characteristic? What's the last characteristic? It's symmetric. So when a distribution of an athlete's performance is symmetric, unimodal, and bell-shaped, we can often use a normal distribution model. I'm not sure yet. A normal distribution model. And you can use this to make predictions about the athlete's performances. For example, here is the histogram showing the distribution of passing yards for Peyton Manning in his first 176 regular season games between the years 1998 and 2008. A normal curve, the blank is kind of small, so write small, sorry. A normal curve, which is this blue line that you can barely see, that's the normal curve. With the same mean as 259 passing yards and the standard deviation of 74 passing yards is overlaid on the top of the histogram. This should have another parentheses here after the yards. You don't have to put it, but if you want to, you can. It's a typo. So here's an example of our graph. As you can see, the normal curve traces the shape of the histogram pretty well. But is it exact? No, because our distribution curves are predictions, not exact data or exact numbers.
Peppers?
Yes.
I need Martavis.
He is not in here yet. He's not in here yet.
Okay, thank you.
Thank you.
Who else in this class
All right.
do you know named Martavis?
Guys, stop. Guys, I'm videoing. Alright. In fact, no distribution of the performances is going to exactly be normal. It's just not going to happen. However, when the distribution of a performance is roughly symmetric, unimodal, and bell-shaped, we use the normal distribution as a model. And it can be useful for estimating the proportions of performances that we expect between two different values. So we're going to use this data to predict how many performances are going to occur between two numbers. Make sure you get the papers. Because the bars of the histogram represents 100% of Manning's performances, meaning if I added all these bars up, I'd have 100% of the data. The area under the normal curve also needs to represent 100%. This leads to two very important facts about any normal curve. Any normal curve. So you can get caught up. The total area under any normal curve is either equal to 1 being the decimal part of it, or what is 1 in percent? We're going to
1.01.
Nope, if I have the decimal 1.0, what's the percentage of that? 100. So if I have 1 as a decimal, okay, how do you find percentage? You move the decimal place 2 spots to the, so now it's 100%. So a normal curve represents 100% of the data. The second important fact that we have is that the expected proportion of performances between two values is equal to the area under the normal curve between the same two values. Okay? So here's an example. To estimate what portion of Manning's performances that were less than 180 yards, we'd calculate the area under the normal curve to the left of 180. So if 180 is here, this is 180. We want to calculate or estimate how much of the performances are from here to here, underneath the curve. That's what we're looking for. You don't have to scribble on it if you don't want to, but I'm just showing you an example. So if you look at the back, how do we find the number? Okay? It is easiest if you always draw a picture. It helps tremendously. So our question is to estimate what portion of Peyton Manning's performances were below 180 yards. We begin by standardizing the value 180. So if you want to do a rough sketch, because it says always draw a picture, it's going to be, what was my mean, 259? I'm going to look back on my other. Then it did 200, 100, increments of 100. So 0, 100, 200, 300, 400. With my mean here in the middle. There. So if this is my mean, .180 is about here. So I want to find the area under the curve here. This is what we're looking for. This area. Area of the shaded region. Alright. I was just scrolling it up just a little. Okay. In order to help us find the area underneath that curve, we have to find the z-score first. What's the formula? Performance. So what's the performance? 180. Minus the mean, which is 259. What's 74 represent?
SD.
Which is standard deviation. So divide by 74.
Negative 1.07.
It could be wrong. Check it.
I just noticed that.
It's performance minus the mean divided by the standard deviation. That is for your z-score. Put this in a calculator and find it.
Negative 1.07.
Negative 1.07? Really? Okay. Do 180 minus 259 equals divided by 74. I don't know what you typed in either.
Oh, way up here. That standard deviation of 74 yards right there.
Gotcha.
Right there, Dylan.
Mark, do we have
There,
this back?
Yeah.
Oh. Well, I didn't know that.
Alright, so because the z-score is negative 1.07, this means that a performance of 180 passing yards is 1.07 standard deviations below the mean. So whatever my z-score is, this case it was negative 1.07, means that I am 1.07 standard deviations below the mean. It is below because it is negative. So if it's above, it's going to be positive. Okay? Can we use the empirical rule for something that's 1.07? No. Our empirical rule only works if you have 1, 2, or 3 standard deviations perfect. Okay? You can't have a decimal.
So instead, we use a tool called standard normal table.
Yes.
You think I know that?
We're going to use this tool called the standard
I'm not supposed to be.
normal curve. No, not curve, it's table, ain't it? Table. Standard normal table. Okay? So let's look at another example. Okay? So this one's just showing you how to set it up. The second problem is showing you how to find the area underneath the curve. Okay? Do what? Standard normal table. Suppose we want to know what portions of Manning's games. Oh, that's going to be a pain. So I'm going to redraw my graph.
I know.
Okay, so there's my curve with my mean. Curve with my mean. Okay? We want to know what proportion of his games were at least 290 passing yards. Okay, so at least. So I'm going to go to where I think 290 might be, which is roughly here. Is 290 going to be the minimum or the maximum?
Minimum.
At least.
Oh, minimum.
Minimum. So I need to know the area here. What's the first thing I need to do? What do I need to do with that 290 value? What do I need to find? What's this word? What's another name for this? What's another name for this? Z-score. We need to find the Z-score. So find the Z-score of that performance. All right. What was your Z-score? 0.41. Do y'all agree?
Yeah, 0.42, yeah.
Dylan said 0.41.
I think it's 0.42.
Well, you're wrong.
Okay? So that was our Z-score. That's what Dylan said. It's just, we're still talking about Manning.
Here we go.
Okay? To look up the standardized score on the table, you have to use the table that is in the back of a textbook. You will be provided with a table on a test. I just said you will be provided with a table for the test. All right. Look. Look. This is important. It is the very last page in the book. Look, your z-score, when you look the area up for this z-score, hush! When you look the area up for the z-score, notice that Brett, turn around. The area underneath the curve is from here, from your line, from your data, to the left. Somewhere in the front. Alright? It's to the left. So if you're looking for something that's to the right, we have to do something a little different. Our z-score was 0.42. On this page, if you look, are my z-scores positive or negative? On this side of the page, they're negative, but I want what? Positive. So I go to the other side of the page. It is a lot of numbers. And I'm going to try to zoom in. Yeah.
Freaking water. Nice.
All right. When you're looking your z-score up, the first number is 0.4. So you look down until you find 0.4. My 0.4 is here. I wonder if I can make this screen bigger. 0.4. What was my second number? So it was 0.41. So you look here, and wherever your two lines cross, that is your area underneath the curve. So write this number down. 0.6591. 0.6591. Do y'all have it?
No.
0.6591. Alright, it was 0.6591. Okay, that's your area underneath the curve. But is that this way or is it this way? It's this way, right? So that number represents this area. Is that the area we want? No. So what do you think we're going to do?
You gotta subtract it.
Subtract what from what?
I don't really know.
How much is the whole area worth? 100%. Okay.
So you divide
Is that percent?
1,065. Kinda. I mean, basically, like 65.
So
One.
change this to a percent.
69.
65.91%.
Mine is 259.
What's the whole area percent-wise? 100. So it's going to be 100 minus
65.9.
65.91.
Which is you need 34.1.
It'd be 0.01.
It's 34
I do my subtraction backwards.
It'd be 09.
It's
34.09%.
Percent.
Alright?
So if you get
So from here, if you wanted to, you could have left it as a decimal and just subtracted 0.6591 from 1. Okay?
yeah, 100.
The total area underneath this curve is 100. So to find what's on the right side, you have to do all of it minus this. to find what's left. Just like if you know a pizza has 8 slices and Bentley here ate 5, how many's left? You had a pizza that had 8 slices. Bentley ate 5 of them. How many's left? How'd you do that?
3.
8 minus 3, or 8 minus 5. That's the same thing here. You take however much total you had, subtract what's gone to get what's left. Okay? But if this was at most 290 yards, our answer would have been 65. Okay? So if the number you're looking for is your max, the number from your chart's your answer. If it's your min, you have to subtract. Max, answer, min, subtract. All right, there's another type of question we can have. What portions of Manning's performances fall between 180 and 190?
Ooh, I can tell you. Hang on just a second.
So I'm drawing my chart. This is 259, 200, 100,
Do you have to redraw the chart?
0.
Okay.
I mean, you don't have to, but it would keep everything organized if you did. 300, 400. All right. This time we want to know the area between 180, so between here and 290. With this being your mean.
30.9%.
Okay, so we want to know this area.
Just hold.
Okay? Look up on your z-score chart. What did we say the z-score was for 290? What was the z-score for 290?
-1.
That was for 180. What was it for 290?
Do we just do that?
Mhm.
0.659.
34.0.
That's the area. I want the z-score. Do what? 0.41. Okay. And that gave us what number? 0.41 gave us what number from that chart?
Standardized score.
0.6591. Okay? 0.6591. That was the area of from here to here, correct? That was the area from that second line all the way back. Right? Yes, no.
Yes.
Yes.
See?
Okay. Did we want this little section? We don't want that, do we? Is that in between 180 and 290?
No.
No. So we have to figure out how to take it out. Oh.
Erase it.
Okay? So in order to figure out how much this is worth, using the z-score, what was the z-score for 180?
1, -1.
Negative 1.07.
I didn't know.
Using your chart in the back of your book, find the area underneath the curve from the back of the book.
What page?
That
It's
was
the very
our
last
first
page.
homework, and I did. And I got the right
Found
answer.
it.
Yes.
You said find what?
Subtracted the 2 up there.
The z-score.
All I did.
Of what? Negative.
Of negative 1.07. What's the area underneath the curve of negative 1.07?
It's 0.1420 or 1,423.
0.143.
23.
Okay. So the blue is this area. The purple is all of it. So how do I find what's just in the middle?
You subtract them two up there.
You subtract them. So do this minus that.
Why you have to teach it like that?
How'd you do it?
I subtracted 34 minus 65.
Minus the 0.65?
No.
Or just 6? Oh, by the 65.91.
Yeah.
You subtracted these two numbers?
Yeah.
No. The 34 minus...
That and that?
That one, yes.
You can't do that.
Why?
Because
That answer.
that,
That is the purple part.
this right here, is the area of, let's see, the 65 is this area, or the 34 is this area, and then, I'm trying to figure out, okay, give me 1 second, give me 1 second.
Can't do that. My bad.
You can't.
Because
It might have worked for this problem, but any other problem it probably wouldn't work.
See, why does math never have, like, easy loop?
Alright, Dre, what was your question?
Is the answer?
I used the chart in the back of the book.
It does. It's not.
Your answer is this minus that.
So is
What's your answer?
30.92.
I didn't write my answer down.
Yeah.
Put that in the calculator and tell me what you get.
Well, I don't get it right now.
0.6591 minus 0.1423. What's your answer?
Oh, that is like 0.51.
Yes, it is.
And it's like, I think it's right. 7
7,
something.
8,
That's right.
6, 1, 0.5168.
Yeah.
Is that right? So, the proportion of his performances that fell between 180 and 290 is 0.5168. I did this minus that.
So you don't divide those numbers?
No. That's just the topic. That's just the topic. That is the...
I wonder you're dividing to...
It was the Z... This was the Z-score. The area for that Z-score was this. Those are the topics.
Okay, well, I didn't... Yeah, my jacket.
Yeah. I'm gonna find it easy.
So that's your answer. It's not really that hard.
I know, but I'm gonna
You
find it.
just gotta use the chart.
I'm gonna find it.
Alright, so your practice
Can you teach me the Z-score thing?
is these 3 problems. That's your practice.
Oh,
Just gotta do those 3.
can you teach me how to do the Z-score thing? That wasn't
How'd you guys get that? That was supposed to be.